Okay, in this lesson, we're going to be going over linear functions and taking a look at all forms, equations, tables, and graphs. Okay, so first of all, we have three examples of different linear functions here and how you tell the difference or how you tell if a table is a linear function is you take a look to see how much the x value is changing each time. So these are increasing by 1. If the y values are increasing by the same amount each time when x is increasing by 1, then it's a linear function. So if we look 12, if I add 11, I would get 23. If I add 11 to 23, I would get 34. If I add 11 to 34, I would get 45. So since the y's are increasing the same amount each time for every one increase of x, then this is a linear function. We call this a common difference, this positive 11. That is also referred to as the slope. Okay, for the graph, we can see that it does take on a line. So that's the easiest way to tell if it's a linear function. Is it a line? We do need to make sure that these, it's exactly a line. So there can't be any curve to it. And again, the easiest way to determine that is to look at, are these increasing or decreasing by the same amount each time? So if I start here at the bottom, I have to go up 2 and over 1. Again, if I go up 2 and over 1, I get to that next point, up 2 and over 1, and up 2 and over 1. So yes, this is a linear function because the graph is a line, and it has that common, that's the slope, that common slope. Okay, and then equation, we want it to be in the form y equals mx plus b. If it's not in that form, we can rearrange the equation. So if we can get it to that form, then it would still be considered linear. M is going to represent the slope, and b is going to represent the y-intercept. Okay, so if we can put an equation into slope-intercept form, y equals mx plus b, then we know that it is a linear function. So if I take a look at this one is already in the form y equals mx plus b. So it's easy to see the slope is 5, and the y-intercept is 7. And yes, this would be a linear function because, again, it has that form y equals mx plus b. Okay, so the next part we are going to evaluate these different functions. So it says to find the value of y when x equals 2 for each function that's given below. And these are 3 different linear functions. And they're the same actually as the functions that were given on that first slide. But now we're evaluating. So we know that x equals 2. We want to find the value of y when x equals 2. So when that's given in a chart, we just go down to where x equals 2, so right here. And we see what y value is associated with it. So for this chart, when x equals 2, y equals 34. So we found our answer, y equals 34. For a graph, you do need to find where x equals 2. So the x-axis is always the horizontal axis, whereas the y-axis is the vertical axis. So if I want to find where x equals 2, I need to locate 2 on the horizontal axis. 2 is right here. But if I want to find the y, I just go up, or it could be down, depending on where the line is. But on this one, we have to go up to get to the point. And we're going to see what is that y value. So again, when x equals 2 for this graph, y equals 1. So we found our answer, y equals 1 when x equals 2. For the last one, because we have an equation, again, we know x equals 2, so we have to substitute 2 in for x. We want to find y. So for this one, we're going to say y is going to equal 5 times whatever x is. So 5 times, we know x is 2, so we're going to put 2 in for x. And then we're going to finish the equation, plus 7. Okay, so we actually have to evaluate this. So y equals 5 times 2 is 10, and plus 7 makes y equal to 17. So when x equals 2, y equals 17 for that last function. Okay, we're going to do another example very similar to the first. This one, again, we want to evaluate y when x equals -1. Okay, so taking a look at this first t-chart, we see that, oh, we don't have the value when x equals -1. So it's in between these two. So -1 would be here. So I have to figure out, well, what is this difference between these y values, this first y value of 20 and the second y value of 12. So if I were finding that common difference, I see that 20 minus 8 would make 12. So now I'm going to split that in half because I really want the number that would be located here. So if I think about that, what I'd have to subtract twice from 20 to get 12, well, that would be -4. Okay, so if I take 20 minus 4, I would get 16. And then let's just double check, 16 minus 4, we do get 12. So when x equals -1, y equals 16. Guys, that pattern should continue for the other values that are missing. So if I fill in those missing values of 1 and 3, let's see if that pattern of -4 is still working. So 20 minus 4 gave us the 16. 16 minus 4 gave us the 12. 12 minus 4 would give us 8. 8 minus 4 does give us 4. 4 minus 4 would give me 0. And 0 minus 4 gets us to -4. So we can see that the common difference here is -4 when x was increasing by 1. Okay, this next example is the graph, and we see 2 points here, but remember we want x, when x equals 1, -1 rather. So -1 on my x-axis is here. So again, we determine whether we have to move up or down to get to the graph. For this one, we have to move up again. And we have to determine how many units do we need to move up to get to where the graph touches. And it looks like it's 5 units up. So when x equals -1, y equals 5 for this example. Oh, and I didn't box this answer over here. Okay, the last example is our equation. Again, we want to know what is y when x equals -1. So this time we're going to plug in -1 for x. So y equals 1/2 times the value of x, which we were given is -1, minus 6. Okay, so -1 times 1/2 gives me -1/2, and we're subtracting 6 from it. So -1/2 minus 6, we could write that as -6.5, or as a decimal if you'd like, -6.5, or I guess we could write it as an improper fraction. So -6 times 2 is -12, plus 1, so that'd be -13 halves. All 3 of those forms are equivalent, and I'll take any one of those 3 forms. Okay. So we are going to plot some points. So just some basic reminders about a coordinate system. We have 4 quadrants and we name those moving counterclockwise. So this is the first quadrant where all x's and y's are positive. The second quadrant has negative x's but positive y's. The third quadrant has negative x's and negative y's. And then the fourth quadrant are positive x's but negative y's. Another thing I'd like to refresh is that this point in the middle at 0, 0 is called the origin. And even though we pointed it out before, x is always the horizontal axis and y is always the vertical axis. When we plot points, we write them as x, comma, y. So this first value is going to tell us what the x value is. So I would move right if it is positive or left if it is negative. So this is going to tell me to move right or left. The y value always comes second. And remember, the y is the vertical axis. So this second number is going to tell me to move up or down, again, depending if it's positive or negative. So up if it's positive or down if it's negative. Okay, we're just going to practice plotting some points. Next. Okay, so here's my coordinate system. I just went 5 in each direction. So -5 to 5 for x's and -5 to 5 for y's. So if we plot this first point, we want an x value of -2. Oops. Let me go back. Sorry about that, guys. Forgot to change it to a pen. So we want an x value of -2 and a y value of -4. So I would move -2 on the x-axis, so that's going to be left 2, and -4 on the y-axis is going to be down 4. 1, 2, 3, 4. So I'd be right here. That's the point. -2, 4. -2, -4. The next coordinate that we want to plot has an x value of 5 and a y value of -1. So for that one, we would move right 5 and then down 1. The next point has an x value of 0 and a y value of 3. So an x value of 0 means I'm not going to move left or right at all. I'm going to stay right in the center, but the y value is 3, so we're going to go up 3. The next point has an x value of -4 and a y value of +2. So an x value of -4, we're going to move left 4, and a y value of +2, we're going to move up 2. The next point is 3, 5. So we're going to move right 3 and up 5. And then the last one, 0, -2. So again, we're not going to move left or right at all. We're going to move down 2 units. I just realized that I didn't pick one that had a y value of 0, so I'm going to add one more to this list. Let's say we wanted to plot the point 4, 0. Okay, so now notice we have the x value of 4, but the y value is now 0. So I'm going to move right 4, x value is positive, but I'm not going to move up or down at all because the y value is 0. So that point would be right here. Okay, we also could see something called function notation. This is just another way to write a linear function. So instead of saying y equals 3x minus 2, you could see f of x equals 3x minus 2. These two equations are actually equivalent. There's no difference between them. Okay, but in function notation, we do have to remember that the x is the input and f of x is the output. Okay, or x is x and f of x is y. Okay, but we tend to call them inputs and outputs when we have function notation. Okay, so this first example, we have an input of 2. So that means that x equals 2. X is always the input, y is the output. So if x equals 2, we need to find the value of y. So we're going to plug x, the x value of 2, into this equation. So this would say 3 times the value of x, which is 2, minus 2. Okay, let's go ahead and evaluate. 3 times 2 is 6, minus 2, that gives me 4. So when x equals 2, y equals 4, right? We get the same result. We have the x value given, we want the y value out. Another way of saying this is f of x equals 4, right? F of x is the output, y is also called the output. Okay, the next example says f of 0. So this tells me the input is 0, or x equals 0. So let's plug 0 in for x. 3 times the x value of 0 minus 2. If we evaluate, 3 times 0 is 0, minus 2 gives me negative 2. So when x equals 0, f of x equals negative 2, or the output equals negative 2. Okay, the last example, the input is negative 1. So in the function, I'm going to put negative 1 in and see what we get out. 3 times negative 1 gives me negative 3, minus 2. Negative 3 minus 2 is negative 5. So the output of the function is negative 5 when the input is negative 1. Okay, and the last thing we're going to do in this lesson is evaluate a graph again, but this time those evaluations are given in function notation. So for this first one, we want an input of 6. That means that x equals 6. We want the output. We want to know what is y. So when x equals 6, I'm going to go to where x equals 6 right here and figure out what the y value is. So this point right here tells me when x equals 6, y equals 1. Okay, so when x equals 6, y equals 1, or I could say f of x equals 1, right? Those two things mean the same thing. So when the input is 6, I get an output of 1. Input 6, output 1. Okay, the next one asks f of 0. So the input is 0, or in other words, x equals 0. Let's go to our graph. When x equals 0, we do not move left or right. We stay right in the middle. And we have to move up to get to the graph. And that y value, or the output, is 5. We can see that at the point right here. When x is 0, y is 5. Okay, the last example, our input is 3. Let's go to where x equals 3. And we want to find our output. When x equals 3, y equals 3. Okay, guys, this concludes the lesson on linear functions.